I teach students how to build robots, and the robots are capable of some pretty amazing stuff. My students compete in a robotics competition, First Tech Challenge, and every year a new game is released for teams to develop solutions for. This year, one of my teams won the national championships in the Netherlands, and that gives them a ticket to compete in the World Championships in Texas, and I couldn't be more proud of them. But after we'd celebrated, I realized, oh man, I gotta figure out how to transport this thing around. And this wasn't just about throwing a robot in any box. I needed a design that could withstand the pain of the airport travel and protect the robot's delicate electronics while still being suitcase-sized and light to fit in as a piece of checked luggage. And today, I'm going to take you with me into my shop and walk you through the complete process of designing and building this robot box. You'll gain some insights into real-world challenges, and I'll even share the CAD files with you so you can make your own box. Let's go get building. At the workshop, I measure up my piece, I throw it on some dungeons so that I don't actually cut into the tables. Then I start making some big rip cuts through these large pieces. Now, a box isn't much of a box unless you have some reinforcing corners here. So I'm going to use this large piece of pie to be able to reinforce my corners. I should be doing this with chop saw, but all I have access to is a jig. Then I go ahead and take that piece I just cut, and I can use it as a jig or a template so I can mark it out. Now what I'm doing here is I'm doing a dry fit. You always want to make sure you're putting your pieces where they need to be and check that it actually fits up as you'd expect. Make it in some pilot holes here. And I'm using this piece again as a little jig so that I can mark out where my parts need to go. And then I'm taking a countersink bit so that I get a really nice flush finish. Here I'm using centrifugal force to pull that wood glue back down before putting some wood glue onto the end of my supporting brace, using my finger, wiping it out. Now I'm doing also measurements here so I know at what points I want to be able to drive my screws in for those supporting beams. Next, I'm going to grab these little T-nuts. You can see there's these little teeth. Now, I'm not using a supporting brace on the bottom here because I'm not too worried about blowing out. And let's start adding in some T-nuts. Now on the side here, I'm getting ready to add in some ring handles. So I'm going to measure out where I want this to be. Drilling in a pilot hole. Now I'm going to go ahead and actually cut out the hole so that my little ring handle can have a space to sit inside. And I'm mounting this through with bolts because 9mm is not going to be enough space for a screw to actually hold in. I'm going to go ahead and take an 1/8" router, and then I'm just going to clean off all the edges. And this really nice little trick that can make your pieces look like they're professionally made without having to be a professional. Now at this point, I'm going and making some mounting holes for that top mounting hardware. Once my front latches are mounted, I'm marking out where my hinges at the back can be. My mom always told me I was supposed to use my head, so this works quite well for tightening in these bolts. And at this point, the box is done. Give it a slap. That's how you know. Now I've got my huge roll of foam here that I'm going to be starting to cut up. This is 2 centimeter thick polyurethane foam here. And this is a great material. It's soft enough to be able to support impacts, but it's stiff enough to be able to actually support the weight of the robot. And with all my pieces cut out, I'm using some spray glue here, making sure that I chose a glue that doesn't melt my foam. And I'm adding spray glue to both sides. This is kind of like a contact cement. You have to let it dry a little bit. And then once both sides are dry, you can go ahead and stick that glue together, and it ends up being a nice permanent connection. It was around this point I realized I made a mistake and I used the wrong piece in the bottom, so I had to pull that piece out and then put in the correct piece for the bottom. I also neglected to keep in track of one of my 2 centimeter pieces, so I had to cut out a little extra here for my lid. Finally, it's time to put on the wheels. Then I head over to my laser cutter and cut out some of the stencils. So, bad boy's finally done. Let's take a look at this thing when it's all together. It's quite nice. We've got some basic padding going on inside. Lots of room for fun and activities in this bad boy. So let's give it a first test and get a robot up inside this. So here's the current robot. It's made a few new changes. We've got some nice aluminum side panels on there. The students had water jetted out. Really nice finish on that. So let's go ahead and get this inside. Now there's all these little cutouts in aluminum. It's a really nice handhold. And she fits like an absolute glove. Plenty of space for this to be able to be taller if need be, and wider if need be in different seasons. So the last step that I need to do is take some smaller pieces of foam here and go ahead and slide them in between certain parts. So for instance, we might take a piece, cut it out, and put it in between the more sensitive electronics like so that when it gets transported, it's got a nice padded sort of cushion for it to sit on top of. So it shouldn't get damaged during transport. I'm also going to add in some extra spacings around the side here with some extra foam, and then a couple foam sheets on top just for that last little extra bit of padding. So I'm going to go measure that up, cut that up. Overall, super happy with how this has ended up turning out. If you made it this far, thanks for sticking with me. And if you found this video helpful, consider giving it a thumbs up and a subscribe for more building content and robotics tutorials. If you have any more questions or ideas for future videos, drop them in the comments down below. And as always, good luck with your next robotics project.